Hello friends, this is the Westcoast Math Tutor. In the last video, we used y equals a times 1 plus r in parentheses raised to the power of t for exponential growth, and y equals a times 1 minus r in parentheses raised to the power of t for exponential decay. Today we are going to learn two more mathematical models for exponential growth and exponential decay, given by a equals a0 times e raised to the power of k times t. If k is greater than 0, the function models exponential growth, and if k is less than 0, the function models exponential decay. Very simple. Let's do an example to make that clear. Let's say the US population was 200 million in 1970, and by 2010 it had grown to 300 million. How can we find the exponential growth function that models the data for 1970 through 2010? We use the exponential growth model a equals a0 times e raised to the power of k times t, where t is the number of years after 1970. This means that 1970 corresponds to t equals 0. We know that at that time the population was 200 million, so we substitute 200 for a0. So we can write a equals 200 times e raised to the power of k times t. We also know that 40 years after 1970, when t equals 40, the value of a is 300. Substituting these both numbers into the growth model gives us 300 equals 200 times e raised to the power of k times 40. Now we can find k. I would really encourage you to pause the video and try. The first step is to divide both sides of the equation by 200 to isolate the exponential factor. So we get 3 over 2 equals e raised to the power of k times 40. Then we take the natural logarithm on both sides, and with the inverse property, ln of e raised to the power of x equals x, we get ln of 3 over 2 equals k times 40. And after dividing by 40 and using the calculator, we get approximately 0.01 for the value of k. This indicates a growth rate of about 1%. The last step to get the growth function is to substitute 0.01 for k in the growth model. So we can write a equals 200 times e raised to the power of 0.01 times t. And we are done with finding the exponential growth function that models the data for 1970 to 2010. Note that t is measured in years after 1970. By which year will the US population reach 400 million? To find the year where the US population will reach 400 million, we substitute 400 for a in our growth model and solve for t. After dividing both sides by 200, we get 2 equals e raised to the power of 0.01 times t. Then we are going to take the natural logarithm on both sides. And with the inverse property, we get ln of 2 equals 0.01 times t. And finally, dividing both sides by 0.01 gives us approximately 70. Because t represents the years after 1970, we have to add 70 to 1970. Which gives us 2040. So the US population will reach 400 million in 2040. Do you think an exponential growth model is the best choice for estimating US population growth? Or might a linear model provide a better estimation? Feel free to write your answer in the comments. And if you like my videos, like, share and subscribe. Thanks for watching and happy learning, everyone.